Well, Sam, how are you doing today?
I'm doing very well, thanks. How are you?
Good. Well, Sam, thank you for coming on. Could you go ahead and give us just a brief background and some of the big things you're interested in?
Sure. Brief background. Hopefully this will be still not too non-brief. Grew up in Buffalo. Have a My family is pretty came from like a pretty medical or science-oriented family. So I was kind of in that mix of like science and interest in thinking about science and technology. Certainly one person who actually had a really big impact on my interest was my grandfather. So he was a dentist, lived to the age of 99.
Oh, nice.
And he was like very, very interested in science and technology and the future and science fiction. And he read science fiction since like the modern dawn of the genre.
Oh,
And
wow.
I think he read Dune when it was like serialized in a magazine. He read like popular science for like, I think like over 70 years straight. And so he was really interested in this kind of stuff. And so obviously it rubbed off on me in terms of my own interests. So in terms of like a little bit about my background, so I was very interested in science and technology. Did an undergrad at Brandeis University in computer science and biology, then continued on for a PhD at Cornell got a PhD in computational biology. Initially, I was very interested in evolutionary biology and kind of computational mathematical modeling of evolution. And then while I was there, I actually got very interested in using those kind of models more broadly to just kind of understand any large complex system. So kind of moving more into the field of complexity science or complex systems. And so it's any large system with lots of interacting parts, whether it was in biology, technological systems, social systems. So moved more into that, began thinking a lot about networks of interacting components. And after I finished the PhD, began a postdoc in kind of the network science stuff. Actually, in the Department of Healthcare Policy at Harvard Medical School. I wasn't doing anything healthcare particularly related. It was just that was where my advisor had the most office space.
Nice.
But it was a lot of like very interdisciplinary work, trying to understand the nature of human behavior, as well as trying to understand. I also during this time getting very interested in how to quantify scientific and technological change. And so some people talk about this as like meta research or meta science or meta knowledge. Also, there's scientometrics, kind of the science of science. I began thinking a lot about this. During this time, I also began doing a lot more writing for general audiences. In addition to writing for other academics, I was also very interested in being able to articulate these ideas to general audiences and kind of to the public at large. So I began writing about math and science and technology, which was a lot of fun. Began actually writing my first book for general audiences. And then after that postdoc, I actually left academia and joined the Kauffman Foundation, which is a big philanthropic foundation devoted to entrepreneurship, innovation, education. And at the time, they were building this almost like a in-house think tank. And I joined them as a senior scholar and kind of got to think about all the different topics I was thinking about, the nature of innovation, scientific and technological change. Did some thinking there around why certain cities are more entrepreneurial than others. And then also began doing a lot more writing. And then now, after I left Kauffman, I joined Lux Capital, a venture capital firm about, I guess, almost 6 years ago now, it's early stage venture, based in New York and the Bay Area. I'm based in Kansas City. And my role is as scientists in residence is to kind of survey the landscape of science and tech and find areas that we should be involved with, and then based on that, find companies to invest in, find people to, sometimes we might build companies around these people, engage with the public through writing and speaking. So I do a whole bunch of that, as well as connect the ideas and the people involved in them that I've been exploring to our portfolio of companies that we've already invested in. So it's a lot of almost like import-export of ideas and people, which is a lot of fun. And so I would say, and the kind of themes that I spend a lot of my time thinking about, and there's many, many different areas that I'm kind of thinking about at any one point, but the overarching themes are around kind of dealing with and making sense of complexity. Either like the complex systems of our technologies that we've built, or the wealth of knowledge and information that is around us that we've kind of constructed as part of kind of the scientific process. And so, the two books that I wrote are about different aspects of this. So I wrote The Half-Life of Facts, which is about how knowledge changes over time, how it kind of like what are the regularities to how knowledge grows and changes and gets overturned, and how error is rooted out and things like that. And then my second book, Overcomplicated, is about how our technologies have grown more and more complex, and increasingly incomprehensible to not just like the everyday user of the iPhone or whatever it is, but even the experts who deal with these technologies on a daily basis, or might have even actually been the ones who created these technologies. And so I'm very interested in kind of thinking about complex technologies, complex knowledge. And then related to that, I'm also very interested in how science works, how sometimes science doesn't work. What are the new types of organizations we might need to actually kind of continue to foster innovation? I'm also very interested in kind of in addition to like new types of organizations for thinking about this, but also like the ways in which people are being trained and they do science. And so do we need more generalist thinking in our kind of age of specialization? And I'm also just very interested in kind of the shape of the future and how science and technology affect society. I'm affiliated with the Long Now Foundation, which is an organization in San Francisco devoted to very long-term thinking. And so I spend a lot of my time also thinking about and what are the long-term implications for these things. So that's kind of a bird's eye, somewhat rambling overview of my background, as well as kind of the things I'm thinking about.
No, I love all of that. And I wanted to just jump right in. One of the things you mentioned earlier was, quantifying technological scientific progress. How do you go about thinking about that?
So this is one of those things where I think it comes down to like, you often have to like be, and I'm not saying like I'm the one being clever about this, but like there's many scientists who've worked on this, but like oftentimes the scientists end up being like having to find ways of being clever about this kind of thing. So in one very and well-known metric is just simply like how often science is cited, or even just like the number of journal articles. More highly cited research would be viewed as more influential. And the number of papers would mean that, there's more knowledge out there. Now, of course, and the thing is like those, and that's clever, but it's also at the same time, like we have to recognize those are just like those are easy metrics to actually quantify. Right. Science and research and discovery, they're a lot more messy than those kinds of things. Just because a paper is being cited doesn't necessarily mean that someone says, this is really influential. And so like to give an example, some people might be citing a scientific paper because they say, actually, I disagree with it and I want to kind of overturn it. Other people would not be citing paper because they're citing certain research because it's so foundational, you just don't cite it anymore. So like very rarely do I imagine physicists end up citing like Newton's Principia whenever they're writing scientific papers. It's just kind of like, it's sort of in the air, and everyone recognizes that Isaac Newton was very, very important and influential, but they're not necessarily citing it. And so you have to kind of caveat a lot of the different ways of looking at these things. And there are many other different ways of looking at how research grows and is overturned. But also, and there's also just even things about thinking about how we like recognizing like how sometimes these metrics are unnecessarily narrow, but also recognizing that not only are they unnecessarily narrow, but in some cases that people use those metrics not necessarily just as kind of like fun rules of thumb, but oftentimes they actually have implications for like hiring or getting tenure and things like that in scientific academia. And recognizing though that these things are still somewhat narrow. And the way I kind of think about this is that there are many activities that are actually valuable for science, but unfortunately only a subset of them are actually valued by scientific academia. And some of that is because that those things are just easier to measure. So one example of this, which is kind of interesting, was there was a paper, it came out maybe, I don't know, decade or so ago, maybe a little bit longer. And it was about looking at researchers whose work was very highly cited. So I had a lot of citations and references. But then they were also looking at people who were mentioned in the acknowledgments at the end of a paper. So they might, and so, because oftentimes at the end of the paper, you'll say, okay, like thanks for this person who maybe helped with some data analysis or just kind of gave some idea, or they were kind of just like in the mix in some way. And this paper specifically looked at people who had a relatively mediocre number of citations, but a relatively high number of acknowledgments at the end of papers. And they found that when those people died, the productivity of all their collaborators actually dropped quite a bit. Really? And so what it showed is that there are these people who are really valuable for science, but we're not necessarily like measuring this or quantifying or recognizing that as much. And I'm not, and which is not to say that therefore the solution is to start quantifying and measuring the number of times you get acknowledged, because I think that'll end up being gamed in some sort of way as well. Right. But I do think that we need to recognize that there are many activities that are important for science, and they're not always easily measured. I mean, you think about like in innovation. I mean, like patents are certainly very valuable, and there are many profound advances in like, especially in like kind of like the software world that have like no patents involved whatsoever. Right. And so recognizing how these things are very imperfect metrics, but still sometimes the best metrics we have are, I think it requires a certain amount of nuance in kind of how we measure it. But that being said, I still think these measurements are a lot better than nothing. And you're actually able to see a lot of really interesting insight in terms of like exponential growth, the number of papers, and like recognizing that, and even the most rough metric. I mean, like there's just far too much scientific knowledge out there for any one person to read. So we kind of know that, even if we don't necessarily know the details. So yeah, there's a lot there.
Definitely. That makes a lot of sense. This question goes off of that. Where do you fall on like the tech stagnation debate? Like, Ross Douthat, Peter Thiel, since 1970, we've got Twitter, but no flying cars. What do you think about that?
So I think it's really interesting. I definitely think there's some like really interesting, like compelling data there. I think and so I do think in some ways we undervalue some of the like information technologies that have been developed over the past 50 years or so. And those things are really, really powerful and impressive. Right. And yes, like we don't have flying cars yet. And kind of like since the 70s, in some ways, it feels like that some of like the kind of like the innovations of like things in terms of like we had like a lot of really great advances around like home appliances and cars and airplanes and things like that in like 100 years before that. And then it's kind of like slowed down. And so, but at the same time, though, I think, yes, some of the things when it like in terms of the innovation around stuff has slowed down a little bit. But I think information technology has not, or at least is maybe a little bit discounted. At the same time, though, I think people are also recognizing that like over the past few years, and some of these things, like some of the advances are beginning to speed up again. So it could just be, it wasn't necessarily this, that we got all the low hanging fruit and now it's just over. I think there's kind of a certain element of like, maybe things just needed to accumulate and then now we're kind of off to the races again. That being said, I do recognize that like, even when you look at these curves, it might require more and more effort to kind of make these advances. I do think actually one interesting aspect of this is how we think is in terms of thinking about like specialization. Oftentimes when a scientific domain or some topic is new, that's when you can kind of make a lot of like easy, not easy discoveries, but relatively easy discoveries, because there's a lot of new low-hanging fruit. Like there's just a lot of new ideas, and then it becomes more and more difficult. And so I think one of the things that we need to spend our effort on is almost like the development of new fields. And I actually think one of the ways in which we can develop new fields is at the intersection of otherwise less connected domains. So not necessarily arguing that we should keep on making like subspecialties and subspecialties and keep on going more and more specialization, but rather kind of recognizing that there's still a lot of space for innovation at the intersection of domains. And I think that's something that's maybe a little bit less valued, but I think could help overcome some of this kind of like stagnation argument.
Gotcha. That makes sense. Do you think academia is just poorly suited to cross-disciplinary work? And is there any way around that?
So I do think to a certain degree it is poorly suited to cross-disciplinary work. And I think one of the major reasons is related to kind of the incentives. And so even if you want to do cross-disciplinary work, you still are housed in a specific department. And the metrics of success and whether or not you get tenure and things like that, or continue getting promoted, is whether or not you can kind of play the game in your own specific domain, in your own specific department. So even if you're doing interdisciplinary work, if it's too interdisciplinary and kind of doesn't really fit neatly into kind of like my department plus, but it's rather like my department kind of, but also this other thing, then you either have to be measured by multiple different departments, or you kind of are fitting in somewhere halfway kind of in between. So it can be pretty difficult. That being said, I mean, there's a lot of interdisciplinary centers and institutes and universities. And so I think a lot of like academic organizations really try to kind of make sure that this is not a problem. But, and I would say, I mean, so there's kind of, I guess there's kind of two aspects. There's whether or not you're doing interdisciplinary work. So whether or not it's like I'm a specialist in one field and I'm working with a specialist in another field, and we are together doing work that is interdisciplinary, or whether or not I am an interdisciplinary individual, like whether or not I kind of cross lots of different disciplines. And so I think, and there's problems though in both, but I definitely think the two specialized individuals working together, that is much more straightforward in academia.
Gotcha.
being an interdisciplinary individual, I think is very, very tough because it's very hard to kind of know where you fit. That being said, even kind of having interdisciplinary teams is still tough because I think you have to overcome jargon barriers, like just being even able to know, like, are we talking the same thing? Like, are we talking? And you can actually see this. Like, people have done some interesting research, and they found that because of these kind of jargon barriers, certain scientific advances or probability models, mathematical models, they've been reinvented like many, many times in different domains because no one realized it. So they were just talking about the same thing, but it was named one thing in one area, it was named another thing in another area. Yeah. And so you see this all the time. And actually, I can remember, I think it was when I was a postdoc, I was on this email list around network science. And so because it was network science, we had a lot of people from lots of different domains.
Yeah.
And so someone would email, maybe like a physicist would email and say like, oh, like, does anyone know of a metric to do the following thing around social networks?
Yeah.
And then someone else from sociology would email back and say like, oh, this has actually been known for like 30 years. And so it was just like, and so in this case, we were actually talking to each other, but if you had asked, like, people would not have known. And so I still think there's, it's tough with those. And I've actually seen some research where I think people have argued, or like they found some evidence that the more interdisciplinary a team is, I think it was like the lower the average payoff in terms of like impact of the research, but the higher the variance. So the idea would be like, for the most part, you fail or you don't do as well, but when you do succeed, you succeed in some sort of spectacular fashion. So I think, and which oftentimes in research and academia is the question of, okay, is the university model well suited towards that kind of like high risk, high reward kind of model?
Right.
And sometimes it is, and you could argue, oh, like, once you have tenure, then you can take lots of risk, but oftentimes that is not necessarily the case. And so whether or not it's like high risk research or research that might take a longer amount of time than kind of the life cycle of a grant cycle, these kinds of things just often don't happen as often. And so, yeah, so I think there are a number of barriers to kind of being able to do that kind of thing in academia.
That makes sense. That reminds me of a paper that blew up a couple of years ago on Reddit. I think it was on like a Reddit math forum, but it was a nursing paper where they invent the way to get an area under a curve.
So
you know, it's like, oh my god! I
actually mentioned that. So in the Half-Life of Facts, yeah, I actually just I think this is there was like this paper where it was like basically like reinventing like I think it was like the trapezoidal method for like integral calculus or something like that. Yeah. And yes. and to the credit of that domain, like a lot of people wrote in, I think, into that journal article, like into the journal, like after it came out, saying like, this is like Newton and Leibniz developed this. Like, yes. This is not like anything novel. But at the same time, though, like, yeah, like that just kind of shows like that's sort of like an extreme example of, yeah, like it's really hard to be able to know all that is out there. Like, and people have talked about this for decades. And there was there was an information scientist in the mid 1980s who he wrote this paper about what he referred to it as undiscovered public knowledge. And so the information scientist Don Swanson, he said, okay, like, let's do this thought experiment and imagine that there's somewhere in the literature some paper that says A implies B, and somewhere else in the literature, could be in maybe a somewhat different subspecialty somewhere else entirely, there's another paper that says B implies C. And so even though if you read both these papers, you would say, okay, maybe actually A implies C. You can actually draw a connection between them because of the vast amount of knowledge. Like, no one has actually read both papers. And so he said, okay, this is a fun thought experiment, but let me test it. And so he used kind of the then cutting edge technology of, I think he was using like the medical database Medline, and he was doing like keyword searches and saying like, can I find something that's like just out there? Like it's undiscovered, but public knowledge. Like, it's knowledge that's out there, but no one has actually connected it together.
Yeah.
And he actually ended up making some discoveries. I think he found a number of different things, including one where he found a relationship between consuming fish oil and actually helping alleviate the symptoms around some like circulatory disease, a circulatory condition. And then I think he ended up publishing it in a medical journal. And even though he was just, and he was not a physician, didn't have any medical expertise, but he realized that there was just knowledge that was being underappreciated. And since then, people have tried to create more automated, more sophisticated techniques for this, but there's still so much out there. And I often feel that if we just stopped publishing new papers today and said, okay, let's take like a 5-year moratorium and just delve into what's already out there and try to find interesting connections of things, we would still be making a lot of really interesting advances. And so I think there's a lot of space there for just finding what is already out there and finding new ways to kind of navigate and cross-pollinate and kind of interconnect different domains within science.
That's awesome. That's awesome. I love that anecdote too. So yeah, just going into these different fields and finding information that's really powerful and being able to apply that somewhere else. And so this goes off my next question. What do people generally just most misunderstand about how scientific discovery actually happens?
I think a pretty good amount to a certain degree. And certainly the things I mentioned in terms of like that, how we sometimes value only a certain subset of things that are important for scientific discovery, and because of that, we end up like incentivizing those activities, and then and sometimes the other things that are still really valuable in terms of maybe like building software tools for science or sharing data. These things, they don't necessarily fall through the cracks, but they're sometimes undervalued. But I think, and I would say one of the broadest things that people sometimes forget about is that scientific discovery, it's a human process. It's done by scientists. And so therefore it's going to be it's not just like, like brilliant hunches and quick analyses. And then just kind of like you write this perfect paper and then it's done. There's a lot of ups and downs. There's dead ends. There's like complex back and forth arguments. There's work being done by irrational people. There's the fact that like a postdoc might have done some research and then decide not going to continue on in academia and then left. And then no one actually knows how to like replicate that kind of thing. Right. Like, it's just like science is done by people. And then I think, but more broadly than that, also we need to recognize that science, it's not just science is not a body of facts that we just memorize. And science is really, it's a rigorous process of querying the world. And so science is a process done by people. And so if we kind of say, like science is this perfect, pristine thing, and then we see evidence otherwise, people are going to be put off by that and surprised and concerned, versus saying like, no, it's actually this wonderfully human endeavor that people get to participate in, and it's not perfect. And we're going to keep on improving things, and we're going to be like modifying things or having arguments about stuff and constantly figuring out what we know and what we don't know. Like, and that's wonderful. And I love, this story that a former professor of mine in grad school told me, that he was teaching this he was teaching a course and came in on Tuesday, gave some lecture. The next day he read a paper that actually invalidated what he had taught. So he went in on Thursday, the next time he was in class, and he said, "Remember what I taught you on Tuesday? It's wrong. And if that bothers you, you need to get out of science." And so he wanted to kind of almost like celebrate the fact that science is constantly in draft form. Like, we're always learning things new. Hopefully we're asymptotically approaching the truth, but the fact that there's a lot of things we don't know. That's the reason scientists work at the frontier. We don't want to work at all the things that are kind of known in the textbooks. You want to work at where there's still all the arguments and the back and forth, and where there's things that maybe are real or maybe just statistical noise. That's where it's really exciting. And so I think, I would say, people sometimes forget that scientific discovery is done by humans and scientists, and it's an amazing endeavor. It's always in draft form. We kind of need to revel in the fact that we're always learning new things and overturning things, and just working with as people. So I would say that that's certainly one thing.
Yeah, no, that's really important. People are working under all these different constraints, and it's just it's not a perfect process. It's not just this perfect diamond that works flawlessly all the time. The Overedge Catalog, what is it, and how did you first have the idea to put something like that together?
Sure. So the Overedge Catalog, and to kind of take a step back, and so when people often think about science or innovation or kind of how research is done, they often think of it as being done in a few different places. It might be done in in a university or in a corporate industry lab, or maybe even sometimes in a tech startup. But the truth is those are really just those kind of organizations are just a few different points in some what is really a vastly high dimensional space. And the truth is that high dimensional space is often underexplored. And so the Overedge Catalog is really my attempt at identifying some of the organizations that don't really fit kind of the traditional institutional models. But I would almost say they're kind of the misfits for organizations. And I'm using misfit in the best possible way. And some of these are for-profit, some are nonprofit, some are residencies, some are not. So some are kind of distributed collectives. But they're all trying to kind of rethink institutional design and kind of doing research or kind of thinking about the progress of knowledge in some kind of interesting way. And so the way I kind of came up with this, I'm not really sure if it kind of came up with it in any specific moment, but over the past number of years, I've been thinking a lot about new types of organizational structures. And I've always been intrigued by these kind of weird outlier groups. And by the way, so the term overedge comes from this term in cartography where you have a map, you have a border, but occasionally some like the information on the map kind of like seeps over the border where maybe like a little
nice.
like a little bit of a river needs to go, or the edge of some mountain range kind of goes beyond the border. And those are referred to, at least in this one glossary that I found, as overedges. And I thought, oh, this is great. Like, this cool. Kind of these interesting outliers. And so I've just been trying to kind of find and I've always been intrigued by these kind of outlier organizations. And so I've been talking to a lot of them, trying to cataloging them. And at a certain point, I realized I had a whole bunch of just like information and knowledge about these things. I should just kind of put it online. And there are other people who've kind of done somewhat similar lists or kind of collections from their own perspective. And I must admit that my listing of the organizations within the Overedge Catalog is a very subjective list. And so since I began publicizing the Overedge Catalog maybe like a few months back. Since then, a lot of people have kind of written to me with suggestions of like either their own organization or other organizations that they're just familiar with, and saying like, oh, maybe this is one that you should be including. And some of them fit, some of them don't. And whether or not they fit or don't is very much like kind of my own judgment call. And I'm still trying to find trying to figure out how best to articulate what these organizations are. But I just kind of view them as ultimately these are organizations where when you kind of describe, like if you were running one of these organizations and trying to describe what you're doing, there's going to be a certain amount of like struggle and confusion initially. Right. And if you're kind of struggling to figure out where you fit, that often means you're doing, like, at least from my perspective, you're doing something really interesting. Right. And so when I developed this catalog, I wanted to publicize it. One, and I would say, first of all, just because I think these are the kind of places where interesting people with interdisciplinary interests can actually thrive. But I also want these organizations to realize like there's a community here. Like these organizations are not alone. And the truth is a lot of these organizations are familiar with each other already. So it's not like I'm like introducing them to this whole new world. But I think for many people, as people think about starting new organizations, they can realize that even if you're kind of going along a path that is less trodden, there still are people that you can talk to and kind of work with and discuss things with. And so, and I've had some interesting conversations with people who are kind of in the beginning of starting these organizations and kind of thinking about all this kind of stuff. And it's been, since I kind of began publicizing the catalog a few months ago, it's been this like wonderful experience just talking to all these interesting people who are running these organizations, who are thinking about these organizations. I just want there to be more. I kind of view it as like, we need to begin populating this high dimensional space. Will these organizations continue? Like, are they going to all be still out there in like 10 or 20 years? I don't know. But I kind of view it almost as like evolutionary process where in the beginning, I want there to be a Cambrian explosion of all these cool organizations and hopefully some of them will survive. And like, maybe we will hit on some really interesting attractors within this high dimensional space that then will be the new kinds of, sort of like established models that people can actually emulate. So it's really exciting stuff.
That's awesome. Are there any that are particularly interesting that you think, I don't know. I don't want you to pick favorites if you don't want to. But,
I'm not sure. And I want to, I don't necessarily want to pick favorites. I certainly think that like certain like organizational models or like revenue models are kind of interesting, like whether or not it's like trying to have like certain like corporate sponsorships or kind of, or creating certain types of like reports that people can subscribe to. I definitely think that it's very interesting to see some of these organizations that are kind of trying to blend both research as well as sometimes like education. And so there's like these interesting organizations that are doing residencies or education model, or having an educational component or having research components. And really, I would say, and as long as they're kind of doing a non-obvious combination of things, I think that's really interesting. So if it's like trying to act as like basically acting as a startup and building a product, but also actually incorporated as a nonprofit, that's interesting. If they're a for-profit, but they really don't have a product and they're just kind of doing a lot of research, that's also really interesting. And so I just think these like non-obvious combinations within this high dimensional space are fascinating.
That's awesome. I love that. That reminds me of it used to be Xerox PARC, Bell Labs, big names, and the big tech companies do have research labs like this. I think Google does, Facebook does. I'm not sure about the others, but it seems like they're not producing the same, and maybe they are, we just don't hear about it, but I hear Bell Labs, I hear Xerox PARC, I'm like, oh man, I know they produce some really important stuff, but the big tech companies today, that seems to be less the case. Do you have that general feeling, or do you think that's just kind of misplaced, just a PR thing?
So, and definitely, I mean, Xerox PARC and Bell Labs, like they made a lot of really interesting innovations. And the truth is, one of the things I wonder about when people kind of think about these kinds of things is like if there's a certain amount of like survivorship bias or like hindsight bias, where
Gosh,
I mean,
right.
for all, and I imagine there were a lot of research labs in like the mid 20th century, and I don't know to what degree. And like I'm just not aware of many of them, so it could be we
Right.
only hear about the successful ones. That being said, I mean the reason Bell and Xerox were able to kind of do so well is because they had these like pseudo monopolies or some
Right.
effective monopolies, and so they had a lot more flexibility. And so that being said, I mean Google and Facebook are pseudo monopolies as well. Right. And so like yeah, so maybe they could do that kind of thing. And so I think and there are, and I've read a lot of analysis about the kind of things of like what distinguishes Xerox PARC and Bell Labs from these other kind of things, from these other kind of more modern organizations. Yeah. So I would say two things. One is I do think some interesting research is coming out of the current labs. It might take a certain amount of time to kind of recognize some of those kinds of things. Sometimes it also could be that some of it is being productized in a way that we don't necessarily associate with research. So like, for example, gotcha. Like I'm pretty sure the newest version of like Google's translate function came out of like Google Brain, like all their research arm.
Oh wow.
And it's unbelievably good. But we kind of think of it as like a product, but like it's unbelievable. I mean, and like when I think about like the translation from like, I don't know, like was like the late 90s, early 2000s, there was like babelfish.com. Like it was terrible. And now it's like you can read newspapers in other languages, and like it's not perfect, but like it's extremely really serviceable. And so I'm not sure we should like undercount some of what's happening, but I do think there are kind of interesting institutional structure components around like Bell Labs and Xerox, and so like certainly like Xerox PARC. Like one of the things that I think people maybe sometimes like underappreciate is not just like the collection of raw talent and just kind of like the brains that are there, but also the people who almost like ran interference between the lab and the corporate structure. And like the people who are willing to say, okay, like I'm going to run interference and let you do your thing and kind of protect you from all the corporate bureaucracy and other kinds of things. Those kinds of people I think are really, really important. And I imagine to a certain degree, those kinds of people exist at like the large corporate industry labs of today. But I definitely think being very deliberate about that kind of thing is extremely important, and then something we sometimes like don't focus as much attention on.
Gotcha. So maybe protecting and like building this little enclave where you're safe from all the paperwork and everything's really important, and just having freedom.
Having the freedom, and sometimes even just like the time, because I think a lot of things with like, and with research, like research just takes time, and it's very hard to kind of say, okay, like I'm doing research. I don't really know what's going to come out of it. It's going to be really interesting. And I also will have you something like, I'll have something to you in like a year or even 6 months. Like there's like a slow burn, like it takes time. And so, and I think being able to kind of protect a group of researchers for a certain amount of time is also very important. That being said, I mean, a lot of in these organizations, like the ones, even the successful ones, like they had like a certain sweet spot in time when they were doing a lot of their things, and like some of them are kind of still around to varying degrees, but they're not necessarily churning out the same kinds of like Nobel Prize winning research or things like that. And so, this is a long way of saying I think there's a lot of factors. Some of it could be just simply like the individuals who are being aggregated. It's the institutional structures around them that is potentially giving them the freedom to do other thing. And some of it could also just be survivorship bias of like, we kind of just only look at the successes and forget that and the truth is, I don't know. It could be that during this like mid 20th century period or whatever, there weren't that many research groups. And so the fact that we only hear about the successful ones is that we only actually hear about all of them. But it could also be that we just hear only about the successful ones, and there were a lot of ones that were just less successful. And I think it's kind of something interesting. And I feel like I should have better data about that. But yeah, I'm not sure though.
That's awesome. Yeah, it's a complicated question, no doubt. Have you read Don Braben's Scientific Freedom by any chance, and his concept of?
I have. I had a chance to go through it. It's really interesting.
That's awesome. Yeah, so we had Don on the show a couple of months ago. Really awesome guy. Yeah, he's like 85. He's still kicking. He's a really cool dude.
That's awesome.
How important do you think scientific freedom is? Is it, Don talks about it as it's like, it's like, the air we breathe. It's like really important to give people flexibility to pursue, the wacky ideas they're interested in. And I tend to agree with him, just think about Max Planck, 20 years to thermodynamics. It feels like it would be difficult for that to happen today. What do you think about that?
So definitely freedom is important, and like having a certain like not having as many constraints is certainly useful. At the same time, though, I still think probably some constraints, like mild constraints, are actually useful in terms of like causing people to get more done. And my sense is like if you look at like an organization like the Institute for Advanced Study in Princeton, that I guess there was like a burst of really interesting work in like the late 40s around like the development of like the modern computing infrastructure. But by and large, a lot of people who end up being there like long term, they've often had like kind of like their best work behind them. Not necessarily always, but it's often like a great place to kind of like just hang out and discuss interesting things. And I wonder, and I guess this is a hypothesis that could be tested. And I wonder if it's because there are too few constraints and kind of too few pressures that it's suddenly you just like, you don't have to feel like you have to kind of generate anything. Now that being said, I think probably a lot of the best scientists have a certain amount of like internal drive. And so whether or not they have constraints, they're still going to get things done. And so I'm kind of arguing both sides of this. But I do think, scientific freedom, certainly in kind of the world we are in, where, especially in kind of like within universities where there's certain incentives and certain pressures on publishing and things like that, and grant cycles. I definitely think we need a lot more scientific freedom.
Gotcha.
And so I think we're nowhere near the point where scientific freedom is going to be a problem.
Gotcha.
But I do think like if we were in that wonderful world where everyone has huge amounts of scientific freedom, then we might want to be a little bit more deliberate about how we think about it, because it could eventually be an issue as well, kind of on the other extreme. But I definitely do agree that we need to create more opportunity for scientific freedom, whether or not it's through granting agencies, how we think about structuring universities, things like that. I think there's a lot of different ways in which we can kind of generate greater scientific freedom.
Gotcha. So probably important, but at the end of the day, incentives do matter.
Yes.
That's cool. Love it. I wanted to kind of take a left turn a little bit here. So, in general, how skeptical should we be of, really easy gains in in biology, especially nootropics and things that make us smarter? It seems like we're already pretty well optimized. In general, is that just a bad place to be looking for, advances?
So it's a good question. I think there's nothing wrong necessarily with looking. Good to look. Right? It would be great if we can kind of find something that helps us never have to sleep or and kind of overclocks our bodies or our brains. But I do think it's unless that we're kind of and not that humans or biological organisms are extremely optimized things, but we have been optimized over long stretches of evolutionary time, and oftentimes that involves creating optimization between extremes, basically managing a lot of trade-offs. And so and you can see this where we're really more we're these messy kludges that have evolved over long evolutionary time, optimizing trade-offs, dealing with things, and we're enormously complicated. And so the idea would be so the argument that you can find something that can immediately kind of cut through complex metabolic pathways and will allow us to kind of change or be improved really easily, I think it's exciting, but I think it also betrays a certain amount of almost engineering naivete, where because we have these engineered systems in technology that we can kind of understand or overclock or tweak, then therefore humans, which are systems as well, they can also be engineered and modified. And but we're not engineered. I think there's some trees in my backyard that actually have these giant, dangerous looking spikes on them. And the reason they're there, the evolutionary argument is that they are there because they're there to protect the tree against the fruit or the seeds being eaten by all the megafauna of North America, which of
Oh,
course
wow.
are extinct. Like
Yeah.
like most of these, like, I don't know, giant sloth or whatever,
Yeah.
these things don't exist anymore. They've been extinct for like 10,000 years plus. But this tree still has them. And so I think, and to argue that like we're these like well-honed machines that maybe we just kind of need to be like tweaked a little bit more. Like we're not, we're messes. And so I think it's, like, I think we can make improvements, and we should certainly try, but it all needs to be done with a certain amount of like humility in the face of complexity, rather than a hubris of like, oh, like we understand how to engineer systems. Like, yeah, you don't know how to you don't know how to engineer systems or like modify systems that have been like subject to constraints over like millions of years, that have like insane numbers of like interconnecting parts. Like this is something that I think a lot of like people from the engineering world who are enamored of nootropics kind of sometimes forget that like biology is like orders of magnitude more complex than technology.
I love that. I love that. It sounds like unless you like, there's some like easy constraint you could see, like maybe, there's this drug you take, it makes you burn quite a few more calories. And then it's like, well, that makes sense. That might be a trade-off, in the
right. Yeah.
environment, right?
It could work, but it's like, you also have like, it could be trade-offs. Like you have to recognize
Right.
that. And
Exactly.
this is like when I think about like, was it like Michael Pollan's dictum of what is it like, eat food, mostly plants, not too much. And he's like, okay, like this is what, and he kind of describes what all these different parts mean, but it's basically the argument of like, we have these traditional diets that have served us well for millennia, or maybe not quite millennia, but like for a long time. And like to mess with them and kind of argue that we're going to kind of break things down into individual nutrient components. I don't think that's a bad idea. I definitely, I am of the belief that like we should obviously be learning more and more about our own biology. I mean, my initial training is in like evolutionary biology. Like these things are great, but to immediately say that like that we can kind of like just walk like wipe away kind of the slow incremental tinkering approach that we've had for a long time, as just like, I don't know, kind of like old wives' tales. Like, I think it betrays a certain amount of hubris, rather than saying like we can learn from it, maybe we can do better. But I think there's something there, and kind of recognize like maybe we need to have a certain amount of humility here.
That makes sense. I like that. Are you down for a round of overrated, underrated?
Sure, let's do it.
Let's do it. So complexity, overrated, underrated?
So I at this point, you probably can tell my obsession with complexity. I would say it's probably underrated, mainly in the sense that I think when people hear the word, they like often just think it's like kind of this like thing that's bad or something to avoid, versus like, for me, I think it's just like, this is the world we're in, and we need to recognize that. And I actually I think it's underrated in the sense that I think people almost don't even always realize that we are living in a world of sufficient complexity, whether or not it's like through these nootropics, as well as, and like even just the technologies we built. So I remember when like around the time like the Apple Watch came out, I think the Wall Street Journal, like a few months later, had this article and like their style section around like whether or not like mechanical watches are still going to be a thing, or whether or not people are going to just start buying smartwatches. And so and there's a quote by this one person they interviewed who was saying like, of course I want a mechanical watch. Like when I think about the mechanical watch and all of its complexity, as opposed to like a smartwatch, which is just a chip. And I'm like, yeah, like, I get like that mechanical watches are complex, but like just a chip, like these things are like so much more complex, but you've been shielded from that complexity. And I think oftentimes when we think about complexity, like we've been shielded from it, and we don't realize how much is out there. And then also related to that, I think we just, like, yeah, it's wonderful. Like we desire simplicity, and like, that's not a bad thing, but I think, actually, things that when the world is more complex, it also just makes the world more interesting. And so, yeah, so I would say, probably a little bit underrated.
Definitely. Yeah. And the example you gave, Apple's, one of their unique advantages seems to be their ability to make things seem like they're very simple, and there's and hide all these complex processes behind.
Right. You often don't even realize how complex they are until they fail, and then you're like, oh, there's a lot going under the hood here, which is not bad, but I think we need to have a little bit better sense of the vast complexity of like the technologies and just the world that we're in, because in a world where sometimes even the experts don't fully understand the technologies they built because they can't grapple with just the massive number of interconnected parts, it's incumbent upon each of us to a certain degree to kind of just be aware of the complexity around us, and maybe have ways of like peeking under the hood, and a computer like throwing up a terminal every now and then, doing some like command line stuff, like having that ability to kind of see what's in there and like how complex things are. I think can actually be a good thing, not a bad thing.
That's awesome. Specialization, overrated, underrated?
I would say overrated. I and people, and specialization is very important. Don't get me wrong. I think specialization is something we need, and we've been able to make a lot of advances, and people who are experts in this very narrow field have allowed us to actually learn a lot about the world. And I think, but related to that though is when we specialize too much, we lose the ability to kind of see connections between different domains, and those, or whether or not it's like overcoming jargon barriers and finding things that have been like been discovered in some other area. Like we need people who can jump across domains, run that kind of import export business of ideas, as well as kind of finding connections and saying like, oh, these two fields should actually they can be productively connected. I think specialization is obviously very important, but one of the other things is that like as we've started doing larger and larger projects, whether it's technological projects, scientific projects, that the only way to do them is to kind of combine lots of different specialists together, which means though, as a result, no one individual really has a sense of what's going on in some large project or some scientific endeavor. And that's not great. Like if we kind of understand things, but only partially, that's not good. Which is not to say that, oh, therefore like a generalist are going to understand everything. But I think we should strive to, and whether it's like the T-shaped individual where people can kind of cut across different domains and maybe have some specialization in one domain, or simply just being comfortable in like learning about new domains. I think that is something that is really important, and it can also just give you like a competitive advantage in the world. If like you can kind of understand multiple different domains and no one else can, that's great. Like you can do things maybe other people can't. So I would say specialization is probably a little bit overrated.
Love it. 1980s computer magazines.
So old computer magazines are fantastic. I think they're underrated. Not just for like the nostalgia component.
Yeah.
I certainly like looking at old computer magazines is like interesting from a nostalgia component, but I actually think they're a really interesting source of like raw material for innovation. I think a lot of people kind of in the tech world and kind of like the whole like Silicon Valley community, they're often pretty ignorant of technological history. Sometimes like proudly ignorant. I would say that's probably more the exception rather than the rule, but most people are just not aware of like the deep history of what's happened in technological history. And we often, because of that, in the same way that sometimes if we can't cut across jargon barriers, we end up reinventing things. We often end up doing the same thing in technological history. Like we end up like reinventing something that has been done maybe like decades before. And so being able to kind of just look at what has come before us and seeing like what were the tools people were trying to develop, or what were the problems people were trying to solve, or what were the killer apps people were trying to make. Like these things are like, in general, the problems that people had, like they're not necessarily going away. I mean, when I think about like the current like no code, low code moment, I mean, that's not like a new thing. I mean, like in like the old Macintoshes in like the late 1980s, like they came with a computer program called HyperCard. And like that was basically like a proto like end user programming, no code, low code interface. And like, so these things like we're not, and the truth is a lot of people kind of who are excited by no code, they often like use kind of HyperCard as a touchstone, but like, it's not like these things are not necessarily new. Like they're kind of like things come in cycles. And it was like Ecclesiastes, there's nothing new under the sun or whatever it is. Like recognizing that like we can actually learn about what is like we'll learn about what are kind of the things that we can be doing, and rather than just kind of constantly reinventing, actually build upon what came before us. I think is really, really important. So 1980s computer magazines, they're amazing and definitely underrated.
I love that, and it sounds like it's a great place to look, because there are things that people could have been trying to do in the 80s that were just not possible due to technology constraints that now are possible. And
right, and I can remember this is maybe it was like in the 90s, but like in a lot of computer magazines, there were just like tons of ads for like simple neural network software and all these kinds of things, and which I mean paralleled sort of like the development within AI, where it was hot for a little while and kind of became less hot, and like kind of ran into some barriers, and then now of course has been able to make a lot of advances. But yeah, seeing just the fact that like it was not just like research being done in academia, like there were like people were selling like consumer software, like there were advertisements for like a neural network software in computer magazines. Like it was great. Yeah, it was fantastic stuff to see.
I love that. Polyphasic sleep, overrated, underrated?
So I guess I'll kind of go back and forth on this one. I would say probably properly rated, in the sense that like most people ignore it and kind of think it's kind of wonky and weird.
Yeah.
But then they're like the people who kind of think it like, but at the same time, like the people who think it's amazing are probably like overselling it. And my sense is, I guess I would say one of the times I kind of looked into it, I never actually experimented with it myself in terms of like changing my sleep habits. But when my son was born, he slept horribly, and I was like, oh, I wonder if there's a way of kind of like overclocking my sleep, or kind of like finding some like quick fix to my need for sleep. And so I looked into it. I mainly realized that like it would just be like it would wreak havoc on like my ability to like interact with like my family and like do things like that. So eventually I ignored it. But I would say actually one of the things that I think about it is the main issue is almost like it's like less whether it works and more about what it says with our like cultural obsession with like the nature of like being busy and like always doing things. And I actually think like the more now that I've actually like my son now sleeps very well. It's been many years since he slept very, very poorly. Like I now can get sleep, but I also realize like I see the increasing importance for like rather than trying to kind of like overclock my sleep and get as much awake time as possible, like there's actually value in kind of going the other way and like taking breaks, or people making lots of arguments about like working shorter work weeks or shorter hours. These things are all, they allow us to kind of not only sometimes work more efficiently or work better. Like there's kind of like there's the efficiency argument, but they also give us a better sense of like helping us figure out what is actually important and what we want from our lives. And so I think, and for me, polyphasic sleep sometimes like is a way of almost like ignoring or kind of like pushing aside that entire deeper question of like, okay, do I actually need to be as awake as I think I need to be? Right. Can I prioritize certain things that I think are important? Can I cut back on my work? Can I realize that maybe I don't need to get as much done as quickly? And so I would say, I mean, it might very well work. And I'm sure there's many people who swear by it and think it's great. Right. But so in that sense, I don't think it's like underrated, but I also think it's like overrated in the sense that like it forces us to kind of, it prevents us from actually grappling with the things that are truly important in like humanity.
Right. No, it does. That's a really good point. It's almost frenetic, right? It's like, oh God, like maybe you should just sit down and think, well, what should I really be doing? What's the highest value activity I can contribute? I love that. The efficient market hypothesis, overrated, underrated?
So this, I'm not really sure. I guess I do think, I probably most people like who are not like professional investors, certainly like most people should operate as if it were true, because I think, and while there are inefficiencies in the market, like they're really hard to find. And so like you should kind of operate as if it is accurate. And so I don't know if it's like underrated or overrated. It's probably like, it's something good that people should incorporate into most of their investments rather than kind of being obsessed with like constantly trying to beat the market or finding inefficiencies. Because unless that is like the majority of your job, like that's right. It is a very tough thing to do.
Definitely. Yeah. I think it's a great point. And I think it's perhaps underrated in the sense it's underrated by most people investing in public markets. And it's like perhaps overrated in certain areas where, people don't have, there's this inadequate equilibria and incentives.
Right. I think part of this is also like depending on like which community you're talking to, it'll be overrated or underrated. Yeah.
Definitely. Love that. Well, Sam, thank you so much for coming on. Do you have any parting thoughts, and where should people go find your work?
Well, first of all, thank you so much. This is fantastic. I had a blast talking about all these different things. In terms of parting thoughts, I don't think I have anything particularly insightful to say. I'll kind of like reiterate the whole thing about like recognizing that like science is a very human process, I think is an important, maybe underrated kind of thing to think about. And also kind of recognizing that complexity is around us, but we can actually kind of sometimes, harness that or kind of appreciate it rather than just trying to like avoid it, I think is something important. In terms of like how to find me online, my website is arbesman.net. So just my last name and then .net. I have a newsletter, arbesman.substack.com, but you can also just go to arbesman.net to subscribe to it. I have left kind of other social media. So that's kind of my major way of interacting is either through the newsletter, where you can also kind of see like other places where I write periodically. I'll often link those. And then my website has a whole bunch of like older writing and other things that I've done as well.
Awesome. Well, thanks so much, Sam. We really appreciate it.
Thank you very much. This is fantastic.
Awesome.